Okay, so today we're talking about matrices. A matrix, I'm going to use a formal definition first, is a rectangular array of numbers. Fancy vocab. I can see an example of a matrix. I have a matrix named A. It's a box with a bunch of numbers in it. Has a row. The first row is 1, 3, -2. Second row is 5, 0, 4. Kind of looks like a spreadsheet with a box around the outside edge. That is a matrix. Has rows of numbers and columns of numbers. Yeah. We usually refer to matrices by their size. Don't judge my grammar mistake. I was writing this at like 11 o'clock last night. M by n. So M by n. We give matrix size, we say M by n. M is the number of rows in the matrix. I'm going to circle them in red. So the rows in matrix A are the side-to-side lists of numbers. And we number them from the top down. So this is the first row. This is the second row. So M for matrix A is 2. N is the number of columns. I'm going to do the same process in a different color. I'm going to go through, circle my columns. Columns go up and down. So this matrix has 3 columns. 1, 5, 3, 0, and -2, 4. When we number columns, we number them like we read a book, left to right. So this is my first column. This is my second column. This is my third column. Bless you. So if I wanted to describe matrix A to somebody, I would say matrix A is a 2 by 3 matrix. And I'm going to write that down because that was one of the questions down here. Matrix A is a 2 by 3 matrix. 2 rows, 3 columns. The reason we need to know that is the type of math that I'm allowed to do with matrices depends on its size. Some mathematical operations have to have matrices that are the same size, same number of rows, same number of columns. Some matrix operations need to have the same number of rows in the first as columns in the second, which is different. One is long, one is tall. So the size of the matrices determines what I can do with them. The individual entries in a matrix, each of those numbers, is described by the row and column that it's sitting in. So I'm going to do another example in that matrix up at the top. If I wanted to label this number down here, the first thing I'm going to do is give it a name. It is part of matrix A. When I talk about the matrix as a whole, I use a capital letter. When I talk about the numbers inside the matrix, I use the equivalent lowercase. So this would be a lowercase a. And then I'm going to write 2 numbers next to the A, the row and then the column. What row is 4 in? 2, good. What column is it in? 3. So this is element 2, 3. Second row, third column. So the first number is the row, the second number is the column. Just like when we label matrices, the first number is the number of rows, the second is the number of columns. It's always rows first, columns second. Good. So I'm going to give you just a minute, and I would like you to pick off in that matrix A elements A, 1, 2, and element A, 2, 1. I'll give you about 60 seconds. A, 1, 2, and A, 2, 1. Okay, give everybody else a second. I'm going to call on some people. You know how I like that name generator. All right, Gerardo. What did you get for element 1, 2? Gerardo got 5. Can I get a thumbs up if you agree with Gerardo for 1, 2? And a thumbs down if you disagree. I see thumbs down. No, we got 0. Do we agree with 0? Thumbs up or thumbs down? I see more thumbs down. Can somebody help Gerardo out? What'd you get, Bruno?
I got 5.
Well, we already went over 5. 5 is wrong. I see 3s on fingers around the room. So here's why that is. Remember, row and then column. Row 1, column 2. First row, second column is right there. Row first and then column. So top row, second column over. That's okay. We're going to try another one. I like pink. Pink is good. That's okay. That's okay. Julie. Julie got 5. Can I get a thumbs up if we agree with Julie? We agree with Julie. That one is 5. If I go and look, 2, 1 is second row, first column. We have to remember row and then column. Yes. You may. I did several minutes ago. That's okay. Go. Just go. All right. Questions on describing matrices? No, just rows and columns. Rows and columns. Capital letters for the matrix, lowercase letters for its members. Good. First operation we're going to talk about is addition and subtraction. Addition and subtraction is nice because if I want to add 2 matrices, I'm just going to add or subtract their corresponding entries. First entry plus first entry, second entry plus second entry. The catch is that in order to be able to do that, the matrices have to be the same size. You will notice I used a word other than size. Dimension, yeah. Dimension. So dimension and size are equal. Those two things mean the same thing. Number of rows, number of columns. So we're going to do the first example nice and slow, and I'm going to do the intermediate step. But after that, I suspect most of you are going to be able to do this in your head. Because once you see the pattern, I think it's going to be pretty straightforward. But let's show the pattern first. So I want to find A plus B. First thing I check, are A and B the same size? Yes. Luis, you nodded your head very enthusiastically. What are the sizes of A and B? 2 by 2. Very good. 2 by 2. and they're both 2 by 2, my answer should also be 2 by 2. I'm going to have 2 rows and 2 columns. And I'm going to add entry by entry. So first row, first column in A is 4. First row, first column in B is 5. So first row, first column in my answer is 4 plus 5. Yay. Do the same thing. First row, second column in A is 1. First row, second column in B is 9. And then we get on the second row 3 plus 0 and 2 plus 7. Add corresponding locations in the matrix. Yeah. Yep. So 4 plus 5 is 9. 1 plus 9 is 10. 3 plus 0 is 3. 2 plus 7 is 9. Ta-da! Hopefully not terribly scary. I see a couple of you saying that. Not bad. Okay. Good. Next one. Same idea. Now it is subtraction. So I want to do A minus B. This time I'm not going to write the steps out. Yes, Bruno? Correct. Sum means add, difference means subtract, and when they say difference, it is first minus second. I'm glad you asked that. When it says difference of A and B, they're looking for A minus B. Good. I'm going to do this one fast now that we've seen the pattern. That first entry should be -2 minus 8, which I'm pretty sure is -10. I don't see anyone looking at me like I'm crazy. Next box is 3 minus 1, which is 2. 0 minus 5, which is -5. And 1 minus 4 is -3. Reasonable? Yeah? Good. I want you to take a second in your small groups and find B minus A. Give you about 60 seconds. I'm going to call on somebody to give me the answer. B minus A.
Oh, B is in negative, but now A is in negative.
Correct. Cecilia, have you found B minus A? No. 8 minus a -2? Minus becomes, yeah, good. 10. Okay. -2. Right. And then 3. Thumbs up if you agree. I see thumbs up. Very good. What do you notice about the relations between those two matrices? sign change, right? Same numbers, but sign change. So just like subtraction between two numbers, subtraction of matrices, the order matters. So if I get it backwards, I'm going to get the wrong sign on all my numbers. So addition, the order doesn't matter, but subtraction cares. So it matters whether it's A minus B or B minus A. Good. Okay. Give you about 90 seconds. We're on speed run. Sum and difference. So A plus B and A minus B. I'm going to call on 2 random students to give me answers. Make sure you work through them in your small groups. Lucero, I don't know, likes that back table today. What did you get for A plus B? Zero. So first row is 5, 4, second row is 2, 5, last row is negative 3, 0. Thumbs up if you agree. Very good, Lucero. Yay! All right, next one, we're going to do the subtraction. Dayanara, what did you get for A minus B? Thumbs up if we agree. I see thumbs up. Very good. So we've got the addition and subtraction. We're just going entry by entry and doing the same operation on the individual pairs of numbers. Good. The next operation is very similar. It says finding scalar multiples of a matrix. Have we seen that word scalar before? No. Does not. Scalar in math means a constant number. There are quantities in math and science that are just numbers. Height, weight. There are quantities in math and science that have a direction in addition to a number. Velocity. The wind is blowing 5 miles per hour east. That's a velocity. It has a number or a size and a direction. Scalars only have the number piece. They don't have a direction. So they're just a number on the number line. But mathematicians like to sound fancy, so they call them scalars. Has anybody heard what they call the piece that has a number and a direction? Starts with a V. Be curious. Is anybody taking physics? It is. Velocity is an example of vector quantity. Yeah, scalars and vectors. Good, so we're talking about taking a matrix and multiplying the whole matrix by a number. And you may have already guessed this, but if we multiply a matrix by a number, we just multiply each entry by that number. Pretty straightforward, yeah? So for example, I have the matrix A, 8, 1, 5, 4. I want to find 3A. So all I am going to do is take every number in matrix A and multiply it by 3. 3 times 8, 3 times 1, 3 times 5, 3 times 4. Pretty straightforward. Yeah. 3 times 8 is 24. 3 times 1 is 3. 3 times 5 is 15. 3 times 4 is 12. Happy face? Yeah. Good. We're going to take that to another level. No frowny face. What happens if I want to find the sum of 3A plus 2B? I'm doing two things. I am multiplying my matrices by constants and then adding the results together. My suggestion, having done this for a long time, is do the multiplication first, write the new matrices 3A and 2B below the originals, and then just add across the new matrices. So that's what I'm going to do. Oops. So I'm going to start with 3A, maybe. And we know now how to do that. I don't have to show my work. 3A, I'm going to multiply every entry in A by 3. So 3, negative 6, 0, 0, negative 3, 6, 12, 9, negative 18. I'll take it I did that correctly since nobody's groaning at me. And then we want 2B. So same idea, every entry in B gets doubled, multiplied by 2. So negative 2, 4, 2, 0, negative 6, 4, 0, 2, negative 8. And what do I want to do with those two matrices? Add them. Yeah, I'm just going to add these guys. That's great. You are faster than I am. So 3 plus negative 2 is 1. Negative 6 plus 4 is negative 2. 0 and 2 is 2. 0 and 0 is 0. Negative 9, 10, 12, 11, negative 26. I see some nodding. Yay. So far, so good. Not too scary. Good. Most of what we will be doing starting on block period on Thursday is that level of difficulty. We're multiplying rows and columns by numbers. We're adding rows and columns together. It's stuff you've been doing since elementary school, but now doing it in batches of numbers instead of one number at a time. Now for the slightly more scary part. We need one more operation, and that operation is when we multiply two matrices. And this is a little bit more complicated because unlike the last two operations, I am not just multiplying entry in A times entry in B. It's 2:30, by the way. Yeah. So the first thing we have to do is we have to check that A and B are the appropriate size. In order to multiply a matrix, the first matrix has to have the same number of columns as the second matrix has rows. So I am checking that the number of columns in A is the same as the number of rows in B. Second number for A matches first number for B. Second number for A matches first number for B. And we're going to check. Before we do the math, we're going to check. Just check. I've given you some sizes for pairs of matrices. And the question is, can we do the multiplication? Yes, Bruno.
Is it like columns and rows, or the rows and columns first?
When we list them as number x number, it's always rows first, column second. Always. Same when we identify elements. It's row first, column second. So I want columns in A to match rows in B. Do those numbers match? Yes, we can do the multiplication. Happy face. I want columns in first to match rows in second. Do they match? No, I cannot multiply C and D together. For G and H, columns in G, rows in H, do they match? Yes, and those matrices look weird. I have 3 rows and 1 column. That's a matrix that looks like this. I don't know why I just tried to make that a box. That's a 3 by 1. 3 rows, 1 column.
And the other one?
The other one is 1 by 5, meaning it has 1 row, but 5 numbers. One big row, yeah. This is called a column matrix, because it is just 1 column. This is called a row matrix. Vectors, which are quantities that have a number and a direction, are often written this way. And that has to do with how we do math with them. They will often be expressed as a column matrix. You won't be asked about this at any point, but it's cool to see. Yeah. We just need to remember columns of first need to match rows of second. Columns of first, rows of second. All right, so we're going to go through a brief explanation of what we're doing, and then I'm going to show you how to do it with an example, because it is easier to do it once you've seen it. The idea is in my matrices, I'm going to take the first row of matrix 1 and the first column of matrix 2, and I'm going to pair them up, and I'm going to multiply matching entries and add the results together. So I am multiplying row I in the first matrix by column J in the second matrix. And this row and this column should have the same number of entries, meaning the numbers should pair up when I go to multiply them. So I'm multiplying matching entries and then adding the results. When we do this, we see an interesting pattern. When I multiply, I'm going to come up here to our examples. When I multiply a 2 by 3 matrix, by a 3 by 3 matrix, the row and column on the inside match. The numbers on the outside become the size of my answer. A times B will be 2 by 3. What about C? If I do that same pattern with C, G times H will be what size? 3 by 5. Yeah. Yeah. So looking at the size, I can predict the size of my answer before I start, so I know how big my answer matrix needs to be, and then I'm just going to work term by term through the answer matrix. We're going to start with one of the easiest possible examples, which is a 2 by 2 times a 2 by 2. So I'm going to scooch you down. You can see example A. It says find A times B. A is 2 by 2. B is 2 by 2. Deep breath. I'm going to write it out long form. After you've practiced enough, you can do this in your head. I've done this a long time. About halfway through my linear algebra course, we were doing this in our head. I don't expect you can do it in your head right now, so I'm going to write it out for you. If I'm doing 2 by 2 times 2 by 2, what size will my answer be? 2 by 2, because the inner 2's cancel, the outer 2's are my size. It's 2 by 2. So it's going to be the same size as the guys we started with. The first entry, row 1, column 1, is row 1 of the first times column 1 of the second. This and this will give me this answer here. And I am multiplying entries that are in the same location, first and first, and then I'm adding those strings of multiplications together. So I'm going to have 1 times 5 plus, and then 2 times 7. First entry times first entry, second entry times second entry, add the results.
Wait, that is the first number or first?
That's the first number in my 2 by 2 answer matrix. I'm going to have 3 more. I'm color coding them so you can visually keep track of what we're doing at a time. That's why we're doing baby steps and why I'm color coding, because it's going to get complicated. Okay, in my answer, I should have a second column. So first row, second column means first row in the first, second column in the second. Because if this is row 1, column 2, I want row 1 and column 2. That's literally what is pulling from those first 2 matrices. So it's 1 times 6 plus 2 times 8. You will notice in that first row in the answer, the numbers out in front of the parentheses are the same because I'm in the same row. It's the second numbers that change because I'm changing columns. Okay. I like pink. Next entry. This guy here. Which row and column am I in? Who can tell me? Second row, column 1. Good. Second row, first column. So second row, first column. So 3 times 5 plus 4 times 7. Good. Good. Last entry. Where am I in the answer matrix? Row 2 and second column. Row 2, column 2. So row 2, column 2. So 3 times 6 plus 4 times 8. Now it's just multiplication and addition. That stuff we can do in a calculator in our head. Yes, Bruno? Okay, well, I want to do it together. You can check my work. Make sure we agree. So 5 plus 14 is 19. 6 plus 16 is 22. 15 plus 28 is 43. And 18 plus 32 is 50. Berna says yes. Jordan also is nodding his head. Brandy's nodding her head. That's good. Good. While you are doing this, and I'm going to give you a little bit of time to work on Delta Math because we got a couple minutes left. While you are doing this, I would encourage you to start Delta Math early on scratch paper. Make that intermediate matrix while you're still practicing the multiplication. Yeah? Once you get the hang of it and you can visually see row times column, then you don't need to do that anymore. But while you're still learning, do that intermediate matrix on a piece of scratch paper. Yeah? When I see you on Thursday, we're going to do a little more practice with this. I'm also going to show you how to use your calculator to do matrix math, including multiplication. Yeah? All right. Does anybody have questions on what we've done so far? No. All right. I'm going to stop our video.